Hi guys, this is the second part of the examples from exercise 2.5 for sketching sine and cos graphs. So this one's a little bit harder. It's a addition of ordinates example really. So we're sketching the combined cos x plus half sine x, or sine 2x rather, for 0 to 2 pi. So let's see, I'm going to maybe make it quite big. So for cos x, that's pretty easy. So we've got just the normal parent graph from 1 to -1, and it will look like this. And that will go to 2 pi. So the period of the cos graph is 2 pi, of course, because cos repeats after 2 pi, and there's nothing in front of the x. There's just the parent cos graph. So notice that when we draw that, we want to sort of see, well, here would be pi. So I might just draw a little dotted line there. And then, well, that's 0. Here would be pi on 2. 2 pi on 2 is pi. 3 pi on 2, and then of course 4 pi on 2 is 2 pi. So that's the cos graph. Now, if we're doing half sine 2x, so the amplitude is half, so that means it's going to go here and here, half and neg half, and then the period is 2 pi divided by whatever's in front of the x, so it's pi. So what this means is that our sine graph has to fit into here. So that's going to be one period or one cycle of the sine graph. So look, I'll draw that, and sine of course starts at 0 and it's going to end at pi, so half of it has to be at pi on 2, and obviously my scale is not perfect, but it's not too bad. So it'll be something like that, and it's going to go through that pi on 2 there. And then my second cycle of it, whoops, too much, is going to go from pi to 2 pi. And then, well, it's going to pass through 3 pi on 2 there. So it's going to look like that. So I'll just get rid of these boxes now. And these are the two original cos x and half sine 2x. And well, now comes the tricky part where you have to draw the actual addition of those two. And look, I'll choose a different colour, maybe, I don't know, green. It's quite different. So I would first go about finding the points that are really obvious, and essentially what you need to do for the same x value, you're going to add together the y values. So here at 0, you can see that you've got 2 points. You've got 0 here, and you've got 1 here. So if we say 0 plus 1, that equals 1. So it means that your green dot, the addition of those two, is going to be on that same spot. Another handy place that we can do is where they intersect. And in this case, they intersect at 0. And 0 plus 0, so the y value of our blue graph is 0, the y value of the pink graph is 0, 0 plus 0 is still 0. So that means the green graph is on 0 there. Another handy point, obviously here for the same reason, and then obviously here for the same reason as well. So 0 plus 1 is 1, and 0 plus 0 is 0. So there's some key points that we can put on, and now we just have to sort of think about what the shape is going to be in between there. So let's see. In between our first dot here and our second dot there, you can see that the pink value and the blue value are both positive. So if you have a positive value, just say, let's say here, half. Half plus whatever this value here is, let's say that this is 3/4. Half plus 3/4 is going to be higher than either half or 3/4 alone. So what that means is that we're going to have the green graph going above there. So if I take this plus this, and it'll be somewhere here. So the height of the graph of the green graph is going to be made from the height of that plus the height of that. So I'm estimating it somewhere up there. And of course, it's not exact. We're not drawing on graph paper. So we are, doing we want to get the shape to be, a good shape, but it's not going to be completely accurate. As we go to the green spot here, we have to get back to 0. So as we do that part, it's going to start on there, it's going to go up, and then it's going to go down onto that green graph. And actually I shouldn't cross over. So maybe like this. Now let's see what happens in the lower section here. So what we see is that the blue and the pink graph are both negative until we get to this point here. So both of them are negative till there. So it means that if you've got, say, a negative value here and another negative value here, your new value is going to be down here somewhere. So they're going to be below both. You're going to be below both of the graphs, and you're going to be below both of the graphs until you get to this point here, because at this point of pi, where x is pi, well, now you're going positive with this. So actually that's going to drag the green graph up over the pink graph. So here I'm going to be below, and I'm going to be below all the way until I get to here. And then, well, I'm starting to get positive values, and somehow I've deleted my sine graph there. Let's just undo that. There we go. Okay. So we can get rid of that. Okay. So I've gone down below until I get to here, and that's where I'm going to start going above the pink graph, but still below the blue graph, because the blue graph is positive. So you can think here might be, let's say, if this is -1, which, well, it is, and then at that point we've got 0. So 0 plus -1 is -1, and then just say this is -0.9. I'm just making up a value. So if that's -0.9 here, and then this is positive 0.2, then -9 plus 0.2 would take us to -0.7. So it means we're above the pink graph there. So that's why we're above the pink graph. We've got to make it back to this green dot here. So we just go in here and we get to there. And then that doesn't look very good. So maybe like this. And then, well, the next part, I've got the pink graph going quite steep there. And the blue graph, it's a little less steep because, well, the pink graph has got to get to 1 in the same, and the blue graph over here, not quite as steep. So we're still going to be above the axis, but it's sort of going to pull us down a little bit. So this blue graph pulls the green graph down, but we're still going up towards that dot. So the green graph would represent cos x plus half sine 2x, and it's not going to be 100% accurate. It's not drawn on graph paper, but it's going to be a pretty close representation. So if I remove those, it'll be something like that it will look like. These are pretty hard, so you want to practice them and trying to get the shape. Your shape might not be exact, but you want to make sure you have the key features and the places where your green graph, in my case, is higher or lower than the pink or blue graph respectively.